Welcome to all on Sethi Lab. In today's session, I'm going to discuss the topic waves plus one physics, in which we are having mechanical waves, electromagnetic waves, and matter waves. In this session, I'm going to discuss mechanical waves. Mechanical waves are propagated in material medium, or propagated material medium having the characteristic elasticity and inertia. Whereas mechanical waves are propagated in material medium having the elasticity and inertia and are governed by the laws of motion and are governed by laws of motion. These topics will be discussed separately. Then plane progressive wave, law of transfer vibrational string, and standing waves. All points are very important points. So I will request go through the session completely. Now these concepts are being cleared by taking 3 questions. One question on this, one question on this, one question on this. Right? Let's start the question. A transfer wave is represented by y equal to 2 sin omega t minus kx centimeter. The value of wavelength for which the wave velocity becomes equal to the maximum velocity. If we have the knowledge of this, its answer can be given orally, right? But before I start the solution, I will clear certain concepts applicable, and if twisting is carried out, we can solve the question also. Concept applicable and solution. Transfer wave motion is that motion in which individual particles of medium execute SHM about their mean position in a direction perpendicular to the direction of propagation of waves. Examples are waves in a string, ripples on the surface of the water, movement of string musical instruments like sitar, etc. Right? Now, in this case, consider horizontal strings such as one hand is in hand and another hand is fixed to rigid support. This type of waves are produced. These are known as the crest, and these are known as trough. Right? This is the maximum displacement in positive direction. This is the maximum displacement in negative direction. Distance between two conjugative crust is lambda by 2, and this is lambda by 4, right? The waves in the string are transverse in nature. The points are what show the position of maximum displacement in the positive direction. The point troughs are called that show the position of maximum displacement in the negative direction, that is downward direction, right? Media for transfer waves. This will be transfer wave can produce shearing stress, such as solids and springs, but not in fluids, right? Next, longitudinal waves. Longitudinal waves are individual particles of the medium execute their mean position along the direction of the propagation of the wave, actual propagation of the wave, actual propagation of the wave. Examples of sound waves, vibration air columns and pipes. Consider production of waves in long pipe filled with air and piston. In this case, we get compression and rarefaction. One term is compression, one is rarefaction. Rarefaction. As the motion or oscillation of the elements of sound is parallel to the direction of propagation wave along the pipe, the sound waves produced in air are longitudinal waves, right? What is compression? A compression is a region of the medium in which distance between any two conjugative particles of medium is less than the normal distance. Hence, temporarily there will be decrease in volume, increase in density. This is the important point. Similarly, rarefaction. The rarefaction is a region of the medium in which distance between any two conjugate particles of medium is more than the normal distance. Consequently, there will be increase in volume and decrease in density of the medium. Means at compression and rarefaction, one is increase in volume, one is decrease in volume, increase in density, decrease in density. Next is fluids as well as solids can sustain compressive strain. Their longitudinal can propagate all the elastic medium. Right? Few characteristics of media for a progressive wave. Steel medium like steel bar. Both transfer longitudinal waves can travel proper, while air can sustain only longitudinal waves. Right? Transfer waves and longitudinal waves travel with different speeds. With different speeds. When they propagate through the same medium. In a wave motion, only the disturbance, only the disturbance through a medium. In the wave propagation, only the disturbance propagate, but the medium does not travel with the disturbance. Right? Waves may be one-dimensional, two-dimensional, three-dimensional. Mode of dimension will be according to the propagation of energy in one dimension, two dimension, three dimension. Transfer wave along a string, one dimension. Ripples on water, two dimension. Sound waves produced from points of three dimension. All these points are important for the purpose of Neet exams and CUET also, because conceptual questions can be asked in the entrance examinations, right? These are very, very important points. Next, displacement relation progressive wave. Displacement relation progressive wave. Transfer displacement is given by y equal to kx plus minus omega t plus phi. Wave velocity. Wave velocity is v equal to f lambda. V equal to f lambda. Wave velocity constant throughout the motion. Wave velocity is constant. And what is k? K is 2 pi by lambda. Angular velocity of propagation. This is known as a angular wave number or propagation constant. 2 pi by lambda. Omega is the angular velocity. Omega is the angular velocity. That is equal to 2 pi f. Right? Particle velocity. Say this is equation 1. On differentiation, equation 1, with respect to t, we get dy by dt. This is the v particle. This is the v particle. It depends on all the factors as given in the expression. Right? This is the equation of plane progressive wave. Plus sign and minus sign. Minus sign moving the positive direction, moving in positive x direction, plus sign moving in negative x direction. Right? Next. Frequency of the wave will remain constant. Frequency of the wave remain constant, unchanged during any type of interaction. So wave suffers because it depends only on the frequency of the source. As I have already indicated above, that frequency remains constant. In that case, now let's start the question. Let's start the question. Question is, expression is given to you y equal to 2 sin omega t minus kx. Y equal to 2 sin omega t minus kx. Given क्या to find lambda. Condition is wave velocity equal to particle velocity. Right? We know wave velocity is v equal to f lambda. That can be reduced 2 pi f lambda upon 2 pi. That is equal to omega upon 2 pi by lambda. That is omega by k. That is omega pi. Particle velocity. Differentiating equation 1 with respect to t, we get v particle equal to dy by dt equal to 2 omega sin omega t minus kx. Right? Now, v particle maximum will be equal to 2 omega, considering all factor as 1. Right? Maximum value sign is 1. Now, as according to question, v wave velocity, that is omega by k, is equal to particle velocity 2 omega. This omega case, k comes out to be 1 by 2. K is equal to 2 pi by lambda. Lambda comes out to be 4 pi. Lambda comes out to be 4 pi. Right? Its answer will be A. Its answer will be A centimeter. Option A is correct. Right? Now, next I will start the laws of transfer vibration of spring. Question is, a sonometer wire of resonating length 90 cm has a fundamental frequency of 400 when kept under some tension. The resonating length of the wave wire with fundamental frequency of 600 under same tension is we have to fill in the blank. Question is taken from JEE in 2004 and applicable for this. Its answer can also be given or leave, but to clear the concept, we should know the laws of means frequency is inversely proportional to the length. Frequency is directly proportional to the square root of the tension. Inversely proportional to the under root m. What is m? M is mass per unit length. Also, inversely proportional to the diameter and inversely proportional to the density. Under root, right? 2, 3, 4. These are the 5 laws of vibration of string. Now, according to question, L1 is given, F1 is given, L2 and F2. Let's see what is given. L1 is wire of resonating has frequency 90 and 400. 90 and 400. 90 centimeter, 400 hertz. 600 hertz, this is to be determined. Now, from this equation, F is inversely proportional to L, keeping T same and using same wire. T same and T same. Then F1 over F2 is equal to L2 over L1. That is F1, L1 equal to F2, L2. L2 will be equal to F1, L1 divided by the F2. On substituting the value, F1 is 400, L1 is 90 divided by F2, 600, right? 15, that comes out to 60 centimeters. Means we have to fill in the blanks. Fill in the blanks is 60 centimeter, right? Laws of vibration of strings. Now clear? There are 5 laws of vibration of strings, right? Now, next I will start standing wave, right? Next is standing wave. Topic of standing wave is being cleared by using this question. Question is, standing wave set up in a medium is given by 4 cos pi x by 3 into sine 40 pi t, where x and y are in centimeter and t in second. To find 3 factors. What is the amplitude and velocity of 2 components wave which produce in this standing wave? What is the distance between 2 adjacent nodes? Distance between 2 adjacent nodes is lambda by 2. What is the particle velocity of particle x equal to 3? No. Concept applicable and solution. What is standing wave? New set of waves formed when two sets of progressive wave trains. Progressive wave train of the same type, that is both are of same nature, both are transfer or both are longitude, having the same amplitude, same time period, frequency, wavelength. These are the essential conditions. Training with the same speed along with the same straight line in opposite direction. Superposed are called standing waves. I think, again repeating, two waves moving in the opposite directions, superimposed. Waves should have the characteristics, both should be either transverse or both should be as longitudinal, right? And having the same time period, velocity and frequency. Now, the resultant waves do not propagate in any direction. There is no transfer of energy in the medium. This is movement along positive x direction. This is along negative x direction. Resultant sum of these two. Net resultant on applying the formula. We know sin C plus sin D equal to 2 sin C plus D by 2 into cos C minus D by 2. Right? Now, resultant will be y equal to y1 plus y2, taken a common. Sin of omega t minus kx plus sin of omega t plus kx. Both are having the same angular velocity, same propagation constant, moving in the opposite direction. One in the positive x direction, one in the negative x direction, having the same nature. Now, if we apply here, sin c plus sin d is 2a, sin c plus d by 2a sin omega t into minus cos of kx. Now, what is A? A is amplitude of each wave. Amplitude of each wave, right? Now, according to question, what is given to you? Direction of y equal to 4 cos, y equal to 4 cos pi x by 3 into sine 40t by sine 40t. In this case, 2a is equal to 4, a equal to 2 centimeter. Means this is the amplitude of each wave. Amplitude of each wave. Right? Now, K is 2 pi by lambda. That is given to you pi by 3. And omega is given 40. Omega is given 40 according to comparison. Omega is given 40. Right? You have to find the wavelength. So 2 pi by lambda comes out to be pi goes 6 centimeter. Distance between two consecutive nodes is lambda by 2, that is 6 divided by 2, 3 centimeter. Velocity of wave V velocity wave equal to f lambda, that is 2 pi f lambda upon 2 pi, that is omega over lambda, 2 pi upon lambda, that is omega by k. Omega is given to 40, k is given to 2 pi by, k is given pi by 3. Omega is given to, what is omega? And this 40t, 40 pi t, 40 pi t, this is 40 pi t, 40 pi t, right? Now, this is 40 pi upon omega. Omega is pi by 3. Pi by 3, that is into 3. This pi by this will, that is 120. Right? 120 centimeter per second. V wave velocity comes out to be. Not to find particle velocity, V particle. To find V particle. Given is y equal to 4 cos pi x by 3 into sine 40 pi by pi t. So differentiating with respect to t. V particle will be equal to dy by dt equal to, this will be constant, 4 cos pi x by 3 into sine the difference in cos 40 pi t into 40 pi. This comes out to be 160 pi into cos pi x by 3 into cos 40 pi t. Now V particle at x equal to 3 centimeter and t equal to 1 by 8 second comes out to 165 into cos of pi x by 3 pi by 3 into x3 into cos 40 pi into 1 by 8. This comes out to 160 pi, cos pi is minus 1 and sin 5 pi. 5 pi means sin 2 pi, 2 pi, 4, so 2 cycles completed, pi. Pi, that is also minus 1. So this comes out to 160 pi centimeter per second. So particle velocity is this one, right? Now I have discussed all the things, how to find the wave velocity, how to find the particle velocity, how to find the lambda, how the standing waves are produced, right? Now I would like to request, if you're new to my YouTube channel, set a subscription and like this video. Please subscribe and share the channel, press bell icon to the receive updates on upcoming concept killing videos on. Thank you. धन्यवाद. बहुत बहुत धन्यवाद.